Hi everyone, welcome back to the 51st video in our series on building a chess engine from scratch in the Java programming language. In this video, we're going to take the Minimax AI that we just finished building and we're going to plug it into our user interface so that when we play a game, we can set it up as human versus human or human versus computer or even computer versus computer. Okay, before I do that, why don't we cover what we've done so far, because it's easy to get lost in the details. We built a working rule engine for chess. We built a basic graphical user interface using Swing, and we built a very simplistic artificial intelligence that uses Minimax and a simple evaluation routine. And now we're going to plug that into our UI. What I'm showing you guys here is the finished product on GitHub on my screen, and I want to show you what that setup page looks like. So under options, we're going to come here to setup game, and you'll see here you'll be able to choose from human computer for white and black, and you'd be able to use this J spinner to set a search depth, and then you'd be able to hit OK to go. Okay, and I don't find that kind of programming particularly interesting, so I'm not actually going to step through that code like I would, the back end, the rule engine. Okay, you can look at that code. It's really not complicated at all. It's in my GitHub repository. I'm going to copy it into the gamesetup.java file in our working version in this video, and we will plug it in to our GUI and get it working. Once we're done with doing that, we're going to move into PGN and FEN file formats so that we can build a database and we can load games that are in progress using standard chess notation. So let's jump right into it here. I'm going to quit out of this project. Close project. Now I've reloaded the project in progress, and I'm going to come over here to our GUI, and within our GUI I'm going to create a new Java class called, let's see, we're going to call this game setup. And I've already copied all of this from my GitHub repository, but let me show you what I would do here. If I were you guys, I would come over here in my GitHub repo under Black Widow Chess, all the way down to game setup. As I pointed out, I don't think this code is really interesting, but I will perhaps walk through it with you guys really quickly. I'm going to copy this. I'm going to come over here and paste it. Okay, there's some compile time errors here, which we will take care of in a second. So let's first deal with this player type. This is an enum that's defined in table. So let's just come over here and pick a place, and we'll say here enum player type, and we're going to say human and computer. Now we've got that, we can come back here in game setup, and that one goes away, and I think the only thing we need to do is delete these two imports, and yeah, that's it. So now we have this. Notice that there are some warnings here, but they're very minor. Oh, this is just telling us these methods aren't used. So let's really quickly walk through this code. Okay, it's just a panel that we've created. It's a J dialog, and it's going to take in a frame, and it's going to center itself with respect to the frame that's being passed in. And you'll notice that there's some radio buttons that are going to be used to select the move strategy for white and black. There's an OK and a cancel button, and there's a J spinner with that search depth that we saw that you could select. Okay, so this is kind of a really uninteresting UI that is going to show up and allow the user to select white or black, being a human or a computer. Okay, so now that this class file exists, the next step will be to plug this in to the table class. So here we are in the table class, and I'm going to write a new method. We have a create preferences menu and a create file menu. I'm going to create a new menu category. So let's say create private J menu, create options menu, right? And we're going to say final J menu options menu is equal to new J menu. We're going to call this options. Okay. And under options, we're going to introduce J menu item, setup game menu item. We're going to call it setup game, and setup game menu item. Oops. Add action listener, new action listener, and this is where we're going to do the work of adding our game setup, and options menu dot add setup menu item, return the options menu, and in here we're just going to say table dot we will say, hang on, what I actually want to do is take the time now to transform the table class into a singleton, which shouldn't be too hard. So but what we're going to say here, let's actually wrap up this idea. We'll say table.get game setup prompt user, and we'll say table.get setup update table.get game setup. So this will, right, so I'll explain this, but the first thing that we want to do is we want to transform this class into a singleton, which should be really easy. We're just going to make this private, okay, and then we're going to come to the the top of the class, and we're going to say private static final table instance. There's really only one table that we show in our GUI, new table, right? And now that we have that, we're going to introduce a way to get a handle to the table. We're going to say public static table get return instance, right? So now that we can do that, the next thing that we're going to get a complaint about is that this method doesn't exist, get game setup. So we're going to have a way to get that. We're going to say, we're going to introduce a private member field. So let's quickly add that right after the move log. And so we'll say private final game setup, And in the constructor here, we'll say this dot game setup is equal to new game setup. And the game setup takes a couple parameters, right? So it's going to be this dot game frame and true. And remember what I said here, that this is the frame that you're centered on, and whether or not the game setup dialog is modal or not, which in GUI parlance basically just means that you know, you have to fill in the information before you can go back to the other frame that you came from. So we're saying yes, you do. Whenever this comes up, you have to fill in the information before you can save and exit out of it. Okay? So now that we have this, oh, forgot a semicolon there, we're on our way. Let's go back to this compiler. So now it's telling us we don't have a method for get game setup. Let's create that method. Public game setup, get game setup, return this dot game setup. And actually, what we can do is probably we can make this method private. It's only being invoked by the GUI. Let's see. And there's a method on here called setup update that we have not defined yet. So why don't I introduce this method, and then I will open a page that will explain really what's going on here. So private void setup update final game setup. And okay, so now our compiler errors have gone away, and what is it that we're trying to accomplish here is that imagine this scenario. A human player makes a move, and when it's done making its move, we want to notify the AI player to make its move. Okay? How would we accomplish that? One way that we could accomplish that is via using the observer pattern. And I've brought up an article here that explains the scenario, right? So there's this red dress example that's given. Liza decides to get a new dress for her 18th birthday party. She goes online to her favorite website, fashionworld.com, and selects a perfect red dress, but oops, it's out of stock. She tries to find another dress, but there's nothing that can replace it, so she goes back to the dress registers. She goes back to the dress, registers her email, and clicks on Notify Me. You must be wondering why I'm telling you this dress story. Reason is Notify Me button is an example of the observer pattern. And basically what they're telling you here is that when this action is completed, you want to send a notification to another agent, right? So in our example, it could be that there's a computer agent playing against a human. It could be that a computer agent's playing against another computer agent. In any case, there's an indeterminate amount of time when some workload may be processed, and when it's done being processed, we want to send a notification that, hey, we are now done. And this is a pattern that helps us do that. And I encourage you guys to read this article. It would take me a really long time to go through the entire thing. But basically, within the observer pattern, you set up an observable, and that thing can be observed by several observers. So, right. So there's an interface called observable where you can add an observer to it or remove it. That's sort of registering with it. And there's a really important method on here called notify observer. Okay, so let's see how that feeds into our example. What is going to happen here is we're going to call, we're going to make our table class extend observable. Okay, so our table is now something that is observable. Okay, And now back in our method setup update, okay, there is a particular method that we can call called, there's two methods actually, set changed, that basically says that, oh, something's changed on the board and I want you to notify the observers. Notify observers of game setup. Oops. Okay. So what this also means is that we want to make an observer to observe the observable. So we're going to say private static class table game AI watcher implements observable. Implements observer, excuse me. Okay. And there's a really important method on here that we have to implement called update. Okay. And this is where what we're going to say here, let me outline the high-level algorithm before we write the code. What we're going to say is if the current player is an AI player, okay, then we want you to make the AI move here. That's really what we're saying here. So when the human player moves and it finishes, what's going to happen is that the current player's strategy is going to be updated to be the AI, and in here is where we want to say go ahead and make the AI move. Okay, so that's what we're going to do. All right, so we'll say if table.get the singleton get game setup is AI player table.get game board. We'll have to write that method current player, right? And if the current player is an AI player and the current player is not in checkmate or stalemate, or excuse me, if the current player is not in checkmate and he's not in stalemate, right? So table dot, so similar code dot get dot, and we'll clean this up, get game board dot current player dot is in checkmate and table dot get game board dot current player dot is in stalemate. Then if that condition passes, what we're going to say is create an AI thread and execute AI work. Okay, we'll leave it at that for now. Let's go back and we're going to create this get game board method. So we have here board panel and a chessboard, right? So what we're going to say is, and we'll make it private because it's really only used in the table, private board get game board, right? So that should get rid of our compile errors, and it does. And here what we're going to say is final, and this class doesn't exist yet, AI think tank think tank, give it a cool name, the new AI think tank, okay, and think tank.execute, okay, we'll have to create those, and while we're in here, we're going to say if, so here what we're going to say is, we're going to use this opportunity to show a pop-up dialog if the game is over and the game is in checkmate, or if the game is over and it's over in stalemate, right? So what we'll say is table.get game board dot current player dot is in checkmate. If the current player is in checkmate, then what we're going to say is J option pane dot show message dialog table dot get board panel. Actually, you know what we'll do for now? I won't. I'll just say system.out. I'll just use system.out.println, and we can look at my source code in IntelliJ in the GitHub repository just to save time. System.out.println game over current player. Game over current player. What we want to say is table.get game board dot current player is in checkmate, right? And let's copy paste, make the change, is in stalemate. So we'll do the same thing for stalemate. So we can come back and clean that up later, or you guys can look at it in my GitHub repository to see how I handled it using a J option pane. It's really not that interesting, and it's you know, it's time-consuming boilerplate code, but you'll get the idea. So here, what I want to do is I want to take the time to introduce the think tank. So the think tank is going to be an instance of a swing worker. So let's say private static class AI think tank extends swing worker, and it's going to have a move and string, right? And private AI think tank. So this is a good way for us to do thread work in a GUI without blocking the GUI thread, right? So if you guys don't really understand what swing workers are, I would encourage you to look it up. Again, this isn't really part of the core part of building a chess engine. That's why I don't want to take up too much time covering it, but it's important to understand these concepts. We've gone over a lot of things, right? So your homework is to look at you know, the observer pattern in Java and those APIs, and as well as a swing worker. So this is really a swing concept. So here what we're going to do is we're going to override the protected move do in background method, throws exception, right? And let's just say return null for now. This is a key method that you need to override. And another really nice method that we get a callback handle to is protected, or public void done, which says when this thread, when this swing worker's thread is finished, this is your opportunity to do whatever cleanup work that you want to do in this method, right? So notice I don't have any more compiler errors, right? So quickly here, what we want to do in this sorry about that. Quickly here, what we want to do in the do background method is we want to say this is where we're actually going to use and invoke Minimax. Okay, guys? So this is our finally the point at which we tie back in to our Minimax search algorithm. So we're going to say final move strategy Minimax. Let's put a new Minimax. And I think we took a search depth, right? Yeah. So we'll say 4 for now. If you want anything deeper, you'd need optimizations like alpha beta, which I've implemented in my GitHub repository. And what we'll say is, so now we have that, and we're going to say, right, best move, final move, best move is equal to strategy, or Minimax, sorry, dot execute table dot get game board, and there you go. So, and then we can say return best move. Now, there's only one piece missing here, which is that we need to tell the move strategy to add an observer. Actually, no, we don't need to do that. I take that back. That's only really, I'm only doing that in my version of the source code for a nice debug panel update. But really, that's all we need to do. So this is what do in background is going to do. And done, we're going to say is final move, best move is equal to get. Again, you have to really read up on, you guys really have to read up on swing workers to understand what's going on here. But what we're saying is this is going to happen in the background, and when we're all said and done, we're going to be in here, and we're going to just call get to get the best move. And now that we've done that, right, so let's outline all the things that we want to do. We're going to get a bunch of compiler errors, but we're going to come back and resolve them. So let's first say table.get.update computer move. This method doesn't exist yet. Best move. Then we're going to say table.get.update game board. Right? Table.get game board. And current player dot make move, best move, right? And right, so let's just put that for there for now. Table.get move log, add move, best move, bunch of things that we're updating here. Table.get game history panel dot redo. This is going to have stuff in it. Table.get taken pieces panel. I'm sorry, get taken pieces panel. Dot redo. Right, we have to update a lot of the GUI components after this move is executed. Table.get board panel dot draw board. right? Table.get.moveMade update, and we're going to say player type computer. Wow, a lot of things in here and a ton of compile errors. I probably set a record for myself. Okay. So let's do the easy ones first. Update game board. Basically we're saying is after the computer makes the move, let's update the board that we're showing, and make move. We want to actually get the transition board. And so we need to write this method, right? And it doesn't matter where we put it right now. Let's just put it nearby. So what we'll say is public void update game board and final board. We're going to say this dot chessboard is equal to board. Okay, that's one down. And we're going to have another method called public void update computer move final move. We're going to be tracking the moves that the computer makes. This dot computer move is equal to move. Obviously this doesn't exist yet, so we just swapped out one compile error for another. That's okay. And we're going to say public move log, or well, let's make this private. Private move log get move log. Return this dot move log. Okay, better. And private game history panel get game history panel. Return this dot game history panel. And notice that these methods are private because we've exposed a singleton that gets us the table, so we don't need to expose these methods to be public. So that removes that one compile error. Private taken pieces panel get taken pieces panel. Return this dot taken pieces panel. Another one down, and obviously the redo methods still need to be written. Private board panel get board panel. Turn this dot board panel. And lastly, we need a private void move made update and final move player type. And for now we'll just leave that as blank. We have to come back and fill that in. So we've reduced our number of compile errors significantly. We still have to look at these redo methods that I've introduced and draw board. So some of these methods already exist, like for example, get game history panel, right? The redo, we're just going to say table. We did that in a prior video. Table.get.getGameBoard and table.get.getMoveLog. Huh, there we go. And pieces panel, table.get.getMoveLog. And draw board, table.get.getGameBoard. There we go. So we got rid of those compiler errors there. And right now I think we only have one more compiler error. This is a lot that we've coded here in this video. So the computer move, right? So we'll probably go over this one in a future video, but let's come to the very top and just say private final move, our private move, computer move, right? I'm not going to make this final because it's going to be changing. And that will solve that compiler error. Okay. So a lot of warnings here. Fairly benign. But let's cross our fingers and see what happens when we launch our program. Oops, table has private access in GUI. Oh, right. So that's because we made this, right. So what we want to do is we want to say, instead of doing that, we just want to say table.get and call a method on here called show. Okay? And let's go into table. Okay? And remember, we made this a singleton, right? And so we're going to introduce a method on here. Right. And that method is just going to be called show. And what did I do here for this? So here I just say public, or actually I can say, let's do public for now, public show. And I can say return. What did I do? Don't remember what I did here. Let me look at my other project. Final, open, recent. This is the finished chess project. Bear with me, guys. Oops. Right. So in this, show. Right. So let's copy this. Okay. And we'll delete that. So, right. It's going to clear the move log history. It's going basically the start of a game. So let's play it. All right. So if we come here and we say, oh, look, options didn't show up. Okay, we have to fix that. All right, I think I figured out what's going on. In create table bar menu, we never added the option menu. So let's say table bar add create option menu. Hopefully that works. We might still have some debugging to do. And come in here, we see now that we have this options, setup game. Hey, look at that. It shows up, and you have the search depth and everything. I think right now I was hard coding the search depth for Minimax to 4, so this isn't really going to be doing anything. But we can say that white is human and black is computer. And let's say that I move. Oh, let's highlight the legal moves. I move. So I don't know if the notification went through. It looks like we have a bug, but at this point, going back to what I was saying, after I make a move, I notify all the watchers of the table, and there would be an AI agent that would be watching the table, and he would get the notification, he or she would get the notification, and then the AI agent would make the move and then notify the table, and then it would be my turn to move again. So it looks like I have a bug to work out. I'll work that out and come back in a second. Okay, I think I identified the bug. Here, after the human player makes a move in the tile panel, remember where we process clicks, in the invoke later method, we want to say, after the board is drawn, we want to say, actually, right before the board is drawn, presumably we could do it here, doesn't matter. If game setup dot is AI player chessboard dot current player, then notify them table dot get dot move made update and player type human has made a move, and then you can do the rest of the stuff. So that was at least one bug. Let's see if that makes life any better. So I'm going to come in here, options, human, white is human, black is computer. And we're going to highlight move so we can see it. Boom. And hopefully black is thinking. Doesn't look like it. What we could do to debug this is, let's go to the think tank code. Let's debug this live on the fly because I think actually this will be helpful for you guys for debugging techniques. I get a lot of questions about debugging techniques. Let's see if we're actually even entering this logic right here. Let's not break anywhere else. Mute the other breakpoints. Mute this breakpoint I had from previously. Start over. Alright, hold on. Okay. Let's start that process one more time. So, let's say that black is the computer player and white's human. Oh, you know what? I'm sorry. I didn't hit this. Okay. Black is the computer player, white is human. Let's highlight the legal moves. And that's interesting. It doesn't look like we're ever going in there. Okay. So let me move made update. Did I implement that? Oh, that's what's going on. I didn't actually write any code there. So move made update. Let's let me show you guys the implementation of that. I basically needed to say that the player moved. So here, there we go. Now that should do it. Alright, so let's see if that, and I actually encourage you guys to write an observable sort of toy program and play with the mechanics because it can be tricky. So let's now run it one more time in debug mode. Options, setup, black's going to be the computer, white's going to be the human. And highlight the legal moves. And of course it still doesn't look like it's doing it. So maybe the toughest bug that we've faced so far. Okay. I'll continue debugging this. Okay, I think I figured it out. So the last thing that I didn't do was I didn't actually set the table game AI watcher as something that's observing the table. So what I need to do is I need to say this.moveLog, and obviously I've done this in my GitHub repository. I just forgot how I've done it. This dot add observer, so the table, and I'm going to say new table game AI watcher. And I don't actually declare this as a separate variable in my program. You could, if you want, make it a member field, but you don't have to. So now that we've done that, let's quit the prior invocation here and try one more time here. Probably one of the most challenging ones that we've done so far. Highlight our legal moves and set black as the computer player. Aha. So now we've hit a breakpoint. We know that work is happening. We know that some kind of work is happening now. Ah, look at that. Black made a computer move. That's how we know we were successful. Wow. So this was a very long video, guys, and I really appreciate your patience. I wanted to get this all done so that we could move on to other aspects of the engine, which include building out the game database. I hope that this video was useful for you guys. I know that it's really hard to sit through a video this long. I'll try to make them a little bit shorter. Anyway, if you like this content, please make sure to subscribe and like the videos. It makes a big difference to the channel. Expect more things in the future. Thanks, guys.